Welcome to our NPTEL courses on DC microgrid system. DC microgrid are now one of the important research topic, as well as it has a huge commercial potential. For this reason, we are now taking these courses on DC microgrid. Our presentation layout will be based on this. First, we will give the overview of the microgrid. With the advent of the distributed generations, the age of the microgrid has come. So, we find lot of microgrid. We can have a AC microgrid, we can have a DC microgrid, and we may have a hybrid microgrid, but our concentration will be on this course on DC microgrid. And we shall see the historical background of the DC microgrid. We shall go back to the days of the Nikola Tesla. So, where actually he proposed the AC system, or those debate will be taken care of, but at that time with the power electronics was in a nascent stage or was not available. For this reason, DC microgrid actually put a back set, but with the advent of the power electronics, now again DC microgrid comes in a full fledged place. Then we shall see the different current situations of the microgrids. So, thereafter microgrid development, which places we can look for the microgrids kind of solutions, what will be its commercial criteria, what should be its population, or the different kind of necessity to make or establish a DC microgrid. Thereafter we shall see that prospects and the financials or the economics behind this microgrids. Then we shall see that actually research based microgrid, that is basically future microgrid in the smart grid, and what are the challenge at present we have on the smart grid. So, now why microgrid and why do microgrid matters? Of course, the reason is that with the greater enhancement of the distributed generation. Now, what we can say that microgrid is a scaled down version of the centralized power system. It can generate, distribute and control power in a small community. It is reliable and flexible. Microgrids are designed to provide uninterrupted power to the balance load demand for a customer with the changing power need. So, these are the balance load and all those things comes into the AC system. So, we are talking about DC microgrid, there we have only the voltage is an issue. Why it is more secure than the centralized grid? The power generated locally and in its smaller size make microgrid easier to keep safe both physically and given the right control system from the cyber threats. So, one can actually introduce the corrupted data in a centralized distribution system or the transmission system, and thus whole system can collapse, but in that aspect our microgrid are resilient from this point of view. So, why it is resilient? Microgrid do not depend on the traditional grid and can be used to supply critical load in case of the grid system is disconnected. Like please recall that in 2012 we in India it has a catastrophic failure, because actually the UP took huge amount of power and whole India grid was collapsed. But anyway, if you have a smart isolated microgrid, this can survive and catering the all the critical load. So, this is his religion. And it can save money, because you need not have to put long transmission line and its maintenance cost you can get rid of. So, using sophisticated software to monitor, operate and optimize the power usage based on the demand, utility price and other factors, willpower, these are many entities you can actually you may not require if you concentrate more on the microgrids. And another major aspect or major feature of the microgrid is that it can store, because of the small size, it is possible to have a proper energy management and incorporate renewable energy. Most of the cases it will have a solar system or a micro hydel or a micro wind turbine in the seashore places or the hilly places. So, it can save money and reduce carbon emission as often required by the government regulations. So, this is quite actually quite fit for our today's requirement. Now, the question becomes definitely how to microgrid work, because there are different entities and ultimately they are virtually, you will find little later every household can be a source as well as load, because if you have put a solar installations and maybe that consumption of the particular house is low, so they will inject power to the grid, and same house after hour or two can become a consumer. So, for this reason we require an advanced control system enables microgrid component to operate, coordinate and optimize. Otherwise, you will have a size of the microgrid will be larger if you do not properly optimize your system. The utility grid, the interconnected system serves as a primary source of everyday power. Microgrid can be islanded or disconnected from the traditional grid during the fault. So, that is what I am saying, that if you have a fault, so you can cut your system from the traditional grids and you can operate with the critical load depending on the availability of your power on that local grid. Energy storage element, so we shall use this abbreviation quite frequent, that is ES, that is most of the cases we will have a batteries stored electricity for use for keeping the power in hand, that will give a autonomy. It means that let us say if you have a solar power plant based system, so you may have a 2 or 3 rainy days, then you require to supply power from the storage battery, that is called autonomy. So, storage power will come, will serve to meet the contingencies of those conditions. Now, next important aspect of the DC microgrid is, or the microgrid is, that controllable generations provide stable and necessary levels of the voltage and the frequency of the system. If it is a AC system or a hybrid system, in every point you have to maintain the frequency, and if it is a DC system, so you have a DC bus and you require to maintain its voltage every point as prescribed within a limit of tolerance, and in AC of course you require to maintain both voltage as well as frequency. Now, there are few entities that we will find that quite critical while discussing on the microgrid. One is non-controllable generations. Most of the solar, because you do not have a control, because you can control, please recall your thermal power generations or the your hydel power generation, where you can open the throttle of the valve and you can control, you have a governor to actually control the flow of the stream. But here solar radiation is not controllable. So, it is not that you can change your control input from the solar and you get you can have the power output as required. So, for this reason we require to meet the reverse. One of the basic problem of the electrical engineer is that we consider that load is something not controllable, we shall try to meet the load by the generation. But here the philosophy is different. Whatever you earn, you are going to spend. That means, whatever generation you do, you will spend that amount of it. And thus, for this reason, you have a controllable, uncontrollable generations. The intermittent input of the source fluctuates based on the factors such as weather, like if it is solar, it is the irradiations and temperature. If it is the wind speed. Example, solar and wind power generation system, and thus you have a controllable load. You have to segregate your critical and the non-critical load. So, critical load has to run always. If there is a non-critical load, for example, I require to wash my clothing. It can be done anytime, and you have a plenty of time in a day, where plenty of the power is available. From that moment it can start and do it. So, for this reason we have controllable load. So, control solutions, for this reason we require to have algo. We have a different kind of energy availability in different point of time. Accordingly you will actually schedule your loading. So, control solution optimize energy uses within a building or the community depending on the needs and the priorities. Of course, if you require to run this washing machine, you may actually require to pay the higher tariff if solar is less. So, managing the microgrid. So, this is something we require to understand. So, who are the stakeholder of the microgrid? So, during outages, that means main grid if it is off, microgrid management systems coordinates with the utility grids and enables the microgrid owner to become in essence the mini utilities. So, it will act itself as a utility. Power can be optimized according to the availability, efficiency and the costs. So, you may have a write off option, then you have to pay the higher tariff. Like if it when the power is available, then power become cheap, you are supposed to do most of the tasks then. When power is costly, you will just run your critical loads. It takes full advantage of the renewable energy sources by optimally dispatching the stable fossil fuel generations or the battery storage to ensure the grid is always operating at a reliable state. So, this is one of the priority area of the microgrid operation. It creates a flexible and the scalable system that can adopt an energy infrastructure plan change over time. So, actually there is a issue, right? You take a dinner at night, thereafter you have a dishwasher and you want the dishwasher to be done at 9 p.m. where there is a peak load, but you do not bother because tariff is same throughout the day. But in a microgrid system, so you will have a timers or you can put it to those dish, because your dishes will be used in the morning. So, at the time at night, maybe when the grid power becomes cheap, you can do that. So, accordingly it has to be scheduled, and thus proper management proper energy management system is required to placed in case of the microgrids. So, now these are our actually content or overview of our course structure that will be on the 8 weeks. So, first what we are continuing today, that will be actually the introduction to the microgrid. Thereafter we shall discuss concept of the microgrid. Each lecture will have a half an hour durations. Thereafter microgrid and the conventional central power system, we will take 2 lectures, that will be 1 hour. AC/DC microgrid with distributed energy sources, we will have 2 lectures. Thereafter power electronics for AC microgrid, 1 lecture. There are power electronics converter in AC microgrid application, there will be 3 lectures. We shall discuss different kind of DC to DC converters here. Modeling of the converter in the microgrid power system, we will take 2 lectures. Thereafter modeling of the renewable energy resources, quite interesting topic, that I will try to cover in 3 lectures, quite challenging though this task. Thereafter microgrid dynamics and modeling, thereafter and its stability, then microgrid operation modes and standard. So, these are the presentation layout of your microgrid topic, DC microgrid topic, and followed by we will have a microgrid control architectures. Then we shall have a intelligent microgrid operation and control, and operating power network energy management for the microgrid. This is the important topic in terms of the energy efficient system. Then we shall see the different kind of architecture, that is DC microgrid technology, system architecture, AC grid interface, that we will try to cover in 2 lectures, microgrids, DC microgrid power modeling 2 lectures, and DC microgrid control 2 lectures. Thereafter application of the DC microgrid and the future smart grids, and linear and the nonlinear stability analysis of the DC microgrid, and conclusions. So, this will be our presentations layout as well as the topic we are going to cover in this course. Now, let us go back to the introductions, that is the background of the DC microgrid. So, we shall cover this as the following topic, that is overview of the microgrid, historical background of the microgrid, current situations of the microgrids, then microgrid development, microgrid prospects, future microgrids in smart grids, and challenges in microgrids. Now, let us see that overview of it. Microgrid can be achieved power balance and the optimal energy allocations over a given area, or as a virtual power source or load in the distribution network. So, it will act as a virtual power source or virtual power plant. It can consist of one or more virtual power plant, that abbreviation we shall use frequently, please remember it, it is VPPs, to meet the demand of the load center, and which can be important office building or the factories, remote residence where the traditional way of electricity supply is expensive. Like you can recall that first DC microgrid base actually microgrid was established in West Bengal in Sagardighi. It was quite long ago in 80s. So, that was basically the remote residence where traditional electric supply is extensive. Compared with the traditional transmission and the distribution networks, a microgrid has a much more flexible structure. And it is not only that, because you can consider a ship itself a microgrid. So, there are many ways you can look at it, a microgrid problem. Microgrid possesses independent control and intentional islanding that takes place with the minimal service interruptions, that mean simplest transition from the grid connected to the islanding operation. If any moment a microgrid decided to go into the islanding mode, it can go to the islanding mode. So, it may disconnect from the utility and it is run independently. So, this kind of system is quite advantageous to self maintenance or self sustainability of the microgrid, and it can utilize and control. DG here stands for distributed generation, not diesel generation mostly, please remember that, is an effective, flexible and the smart manner. So, we shall control the distributed generation in effective, flexible and smart manner. So, few histories of the microgrid we have put into the perspectives. R.H. Lester of University of Wisconsin Madison proposed the concept of the microgrid as long as in 2001, and later Consortium for the Electric Reliability Technology Solutions CRTS and European Commission Project Microgrid also gave their definitions of the microgrid. So, it has started its inceptions from 2001. In 2002 in USA, National Technical University in Athens built a small laboratory of microgrid project known as NTUA Power System Laboratory Facility for test and control of DER, that is distributed electric resources load with the multi-agent technology. Then again in 2003, same Wisconsin Medicine established the small laboratory of microgrid, that is called NREL laboratory of microgrid, with the capacity of just 80 kVA for test and control of various type of distributed loads and its different modes of operation. Now, in 2003, multiple microgrid distribution systems were built across the world, including 7.2 kV microgrid in Mat River Park, Vermont in USA, and the 400 volt microgrid in Kettons Island in Greece, as well as in the Yachi and Kyonago and Haiichi project in Japan. So, in 2004, the CSI this Arcia test facility was built in Milan in Italy, which can be restructured into the different topologies for the steady state and the transient operation state and power quality analysis. So, this was started in Italy. Thereafter, in England in 2005, the Imperial College London Control and the Power Research Center was set up in the London, UK for distribution network prototype states and the load tests. Now, history of microgrid: multiple distribution demonstration projects were successfully built around the world, including Japan Sendai system in 2004, Shimizu microgrid in 2005 and Tokyo gas microgrid in 2006, Spain Lebian microgrid in 2005, USA Sandia National Laboratories in 2005 and Plumdale's Clarwell pumping stations in 2006 and Germany's Mahim microgrid in 2006. So, what is the current situation of the microgrid? Nowadays, the world's power sector is facing challenge due to increasing load and the environmental issues. So, we require to reduce the carbon footprint and we want that same lifestyle required to be continue or lifestyle required to be enhanced in case of the countries like India, where till power consumption per capita is quite low. Low energy, and for this reason what happened, there are environmental issues, low energy efficiency and the users power quality needs. So, that all required to be addressed through the microgrids. Microgrid can utilize the control of microgrid can utilize and control distributed generation in an effective, flexible and smart manner, that we will see how it can be done, and hence can best address these above mentioned problems. Now, microgrid developed in different countries. Of course, USA was first started. The concept of the microgrid was originated in US. The architecture proposed by that is what I have shown few slides ago. CRTS consists of power electronics technologies based on power electronic technology based micro sources with capacity of 500 kilowatts and loads that integrate power electronics technologies based control scheme. In 2003, the goal of the microgrids modernization is set up in USA to widely integrate the IT, that is information technology and the communication technology into a power system to get the smart grid or achieve grid smartness. Microgrid developed in different countries, so in USA also. In the view of the grid modernization, the focus of the US future microgrids are to improve the reliability for critical load, meeting various customized quality demand, minimizing the cost and realizing smartness. Thereafter comes to the Japan. Japan also has contributed in the microgrid in a larger way. In Japan, microgrid is studied with the aim of diversifying energy mix, reducing pollutions and meeting customized demand. The multiple microgrid projects are implemented in Japan. Japanese scholar put forward the concept of flexible reliability and the intelligent electrical energy delivery system. It is called FRIENDS. The FRIENDS expected to flexible AC transmission system, that is FACS, to distributed distribution network to make full use of their advantage in quick and flexible optimized energy control that mix with the energy operation, and thus gives you a very good power quality demand. Now, FRIENDS have become the important form of deployment of the microgrid in Japan, and researchers are considering the system combined with that heat and the power system for the better environmental friendliness and higher energy efficiency. For example, there are few reporting that charging and discharging of ultra capacitor, that is a part of the storage element or the stability. So, it is a huge amount of heat will be dissipated. So, why can't this heat can be used for the water heating purpose? It set up the New Energy and Industrial Technology Development Organization NEDO to coordinate studies and use the new energy among the universities, companies and national key laboratories. So, thereafter European Union, considering the market demand and the power supply and the security and the environmental protection, European Union proposed Smart Power Network program in 2005. It called for the efficient and the close energy centralized generations and distributed generation by making use of the distributed energy sources, that is DER, smart technologies and advanced power technologies. So, put together and they came out the concept of Smart Power Network program. Currently, this theories of operation, control, protection, security and communication has been established and verified in the laboratory for the microgrids. The future focus will be more advanced control strategies, standard demonstrations projects to be built in the foundation of the large scale integration of the distributed generations and transition from the traditional grid to the smart grid. Now, prospect of the smart grid with the advanced IT and the communication technologies, electric power system will develop towards more flexible, cleaner, safer and more economic for the smart grids. The smart grid is intended for power system consisting of generation, transmission, distribution and consumption. It allows for smart interaction between all kind of developing and introducing advanced control technologies, thereby optimizing electricity production, transmission and consumption. And in the smart grid development, the distribution network must shift from the passive to active, which support the DG for the real time participation for the generation and user side in optimization the power system operation. Microgrid is an effective means for an active distribution system, which will help large scale integrations of the DG and transmission from the traditional grid to the smart grid. And last but not least, the use of various type of DGs and storage element, that is ES, in the microgrid helps to conducive energy saving, emission reduction and also we shall discuss all this thing in details, also significantly motivates towards the sustainable energy strategies. The new energy based DG, that is can largely reduce the feeder losses and save investment and transmission distribution losses of the network. It allows for mutual support with the microgrid, utilize available resources and equipment and reliable and utility supply, thereby increasing the energy efficiency and the security of the system. And what are the future? Today's electrical grid must take the challenge to match the modern digital economy and the information age with higher load demand, uninterruptible power supplies, high power quality and high value services. The integration of the various intermittent and fluctuating RES will lead to the reliability problem of the ancillary services, power quality disturbance and brownout and blackouts. New electricity transmission and distribution network is required for integrating newly emerging distributed RES. So, this is the challenge and we require to meet that. So, for this reason we have a future microgrid, and this smart grid is a modernized grid that uses a robust two-way communications, advanced sensor distributed computers to improve the efficiency, reliability, safety of the power delivery use, and thereafter we have the system operator, the control of the electric power, customer level, small scale distributions as well as the storage devices. Communicate informations on operating status and need to collect the information on price and the grid conditions. And last but not least, transformation of the grid under central control into a collaborative network. So, and the SG must incorporate the distributed intelligence and the interactive communication at all levels of the power of the network in order to coordinate power generation in an optimal way to improve the system. And thus, in future SG, the interest for the microgrids are exposed specifically for integrating renewable energy and non-conventional energy resources. Thank you. This was your introduction to the microgrid. Mostly we discuss about the DC microgrids and its philosophy. We shall continue to the next class. Thank you for your attention.